Alright, welcome back. We are talking about equations with exponents today. Okay, the first thing we need to do is differentiate between what I mean with equations with exponents. Okay, first is a linear equation. Okay, a linear equation is something that has an exponent of 1. So an example would be 3x plus 1 equals 4. Okay, because this x only has a 1 for an exponent, because there's no exponent there, so that means there's an exponent of 1. Okay, so this is an example of a linear equation. Okay, another example of a linear equation, we might graph, would be y equals 3x minus 3. Okay, again, because it's got an exponent of 1. Okay, so that's the first characteristic of a linear equation. It means there's an exponent of 1, so our x just has a 1 here. Okay, and then the graph is a straight line, so our graph would look something like this. Okay, the graph of a linear equation is always a straight line. Alright, and a linear equation also has one solution. Okay, so which means if I solve this, I get 3x equals 3, and then I would divide by 3 and get x equals 1. Okay, so there's one solution to this problem. That's the only number that works for this equation. Okay, now a quadratic equation is different. Okay, a quadratic equation is something that has an exponent of 2. So for example, it might be, I don't know, let's go 2x squared equals 32. Okay, so now I have an exponent of 2 right here. Okay, so I got the exponent of 2. And the graph is going to be a parabola or a U-shape. So the graph, okay, is going to look something like this. Okay, of, let's say, y equals 3x squared plus 1. Okay, the graph will look something like a parabola, okay, a U-shape, like that. So that's what the graphs look like. So again, linear equation has a straight line graph. Quadratic equation has a parabola or U-shaped graph. And a quadratic equation usually has two solutions. Okay, I mean we have more than one answer that can make this true. All right, and we're going to solve these today is what we're going to do. Okay, so keeping in mind that we're usually going to have two solutions to this problem. Okay, so let's dive in and start solving problems that look like this. We've done a bunch of these, okay, where we get one solution for x. Now we need to do some of these where this squared here tells us that we're probably going to have two solutions, okay, most of the time. So let's go ahead and get started. Okay, and our objective right here is to solve a quadratic equation. Again, this is a quadratic equation because it's got a squared. We are going to solve these the exact same way that we solved regular equations. We had just an x value. So I need to get the x part by themselves, okay, my 2x squared. So I'm going to subtract 7, or do negative 7 on both sides, and get 2x squared. And 25 minus 7 is 18. Now again, I need to get the x part by itself. So they took it times 2, so I'm going to divide by 2. I get x squared equals 9. Now this is like when we did the Pythagorean theorem problems, okay, where we see this squared here when we had c squared, and we take the square root of it. So I'm going to take the square root of x squared and the square root of 9. Okay, well, square root of x squared, what happens is the square root sign undoes the square part, okay, the 2 exponent. So I'm just going to get x equals, and now I got the square root of 9. So I want to know what times itself equals 9. Okay, now again, I told you that this squared implies that there are two answers to this problem. Okay, well, the easy one is we know 3. Okay, 3 times 3 equals 9. Okay, but that's not the only way that I can get 9 by multiplying something by itself. And here's what I mean. Let's stop and think about how I can get a positive 9 for an answer. Well, I know that I can take a positive times a positive, and that equals a positive. But there's another way that I can multiply to get a positive, and that's to take a negative times a negative. So since 3 times 3 equals 9, I know that negative 3 times negative 3 also equals 9. Okay, because a negative times negative is a positive, and 3 times 3 is 9. So I have two answers, 3 and negative 3. Okay? Now, we can write this like this and leave it as 3 and negative 3, or another way to write this is to put a little plus and minus sign. Okay? And this means positive and negative 3 is the answer. Okay? So x is positive 3 and negative 3. Again, you can write it either way, okay, but this way is what we're going to see on the next slide. Okay, so again, this just means positive and negative 3 as our answers. Now I told you that most of the time when you see a squared, you're going to have more than one answer. Now let me show you a real quick example of when that's not the case. Okay, let's say I get this. And I know I'm supposed to take the square root of both sides. And the square root of x squared is x. Now I'm thinking to myself, what times itself equals 0? Well, 0 times 0 is the only thing that equals 0. And since there's not a positive and negative 0, then there's only one answer. Okay, I can't have negative 0. That's not possible. So this solution only has, or this equation only has one answer. So anytime there's 0 underneath the square root, that's the only time you're going to get one answer. Okay, instead of two answers for your solution is when 0 is underneath here. Because again, we can't have positive and negative 0. But 9, we can have positive and negative 3 as its square roots. Alright, let's go on to the next slide. Okay, let's go ahead and solve this one now. So we got 2x squared equals 16. Again, first step is to get the x part by itself, so I'm going to divide by 2. I get x squared, and 16 divided by 2 is 8. So now I'm going to take the square root of x squared and the square root of 8. Well, my problem is I don't know what the square root of 8 is. Okay? But I know there has to be a positive and a negative version of it, so what I do here is I put a plus and a minus. That means positive and negative square root of 8. Now, I'm not done yet, though, because I did a whole lesson on how to simplify these things. Okay, so I can break 8 down. So if I take the square root of 8, I can break that down into 4 times 2 and 2 times 2. Okay, so the square root of 8 is the square root of 2 times 2 times 2. Again, if I continue to break this down now, I circle these. So I have 2 times the square root of 2. That's what the square root of 8 equals. So my real simplified answer is positive and negative 2 times the square root of 2. Again, it's a squared, and I didn't get 0 underneath here, okay? So I have to have a positive and a negative version, so I'm just going to put plus and minus 2 square root of 2. Alright, and let's go on to another slide. Okay, example 3. The two rectangles are similar. Find x by solving this proportion right here. So I'm going to rewrite this. Now I told you that there's going to be a point in time where we wanted to solve for x, we had to get away from multiply these two and divide by something else. And we had to know how to do cross products. And this is that example. Okay? And here's why. It's because if I'm solving for x, my problem is I have two x's here. So if I multiply these two, I can't divide by x. That's not going to solve anything. So I have to be able to do cross products on this. Okay, so I'm going to multiply cross products. X times x is x squared. Okay, that's what x times x is. Then I'm going to set that equal to 9 times 16. And 9 times 16 is 144. Okay? Well, now we learned that when there's a squared, I'm going to take the square root of it. So I get x equals, and we just learned this, okay, square root of 144. Well, we can have a positive 12 and a negative 12. Alright? Now my only problem here is that only one of those answers is reasonable. Okay? And the answer is 12 centimeters. And the reason is because I can't have negative 12 centimeters. Since we're talking a distance here, we're measuring something, the negative answer doesn't make any sense. Okay, so mathematically, when we solve this, we do have two answers, because 12 times 12 is 144, and negative 12 times negative 12 is 144. But the only one that makes sense in this case is the positive version, because we're talking about a distance, we're measuring something, and we can't have negative distance. Okay, I can't go negative centimeters. And we got one last example for you, so let's move on to it. It says Jaime is making a mosaic using 1-inch square tiles. If the shape of his mosaic is to be a square, about how long should each side be? So what they're telling us is the area in here is 100 inches squared. Okay? Well, we know that the area of a square is a side times itself, or side squared. Okay? So I know that my area is 100 inches squared, and that a side times itself should equal that. So all I need to do is solve for s. So again, to solve for s, I'm going to take the square root of both sides. Okay, so I'm going to get my side is equal to, again, the square root of 100. Well, I know 10 times 10 is 100, so it's positive 10 and negative 10. Okay, so I can have positive 10 inches or negative 10 inches. And again, the only one that makes sense, since it's a real world example, is positive 10 inches. Okay, so 10 inches long is the answer to that question. Because again, we can't have something measured in negative inches. It's not possible. All right, and that's your lesson on solving quadratic equations. Happy homeworking.